the topic of the talk is ASTs, which is abstract syntax trees. We'll get into the details because I'm sure it's familiar to some people. It's like less familiar for other people. And then go into domain-specific languages, which is basically custom languages using then the concept of abstract syntax trees under the hood. And it's a technique that I find really, really powerful that I see in diverse shapes, right? Like you will see it's nothing rocket sciencey, but it's a concept that allows you to do pretty powerful tools once you get to the fundamentals. And it's been born, I've been doing a lot of, LLM assisted programming with GPT-3.5, Turbo, or DaVinci, which had like really small context windows. And so you couldn't really do write even like a whole file of code. So I had to go into something that was more compressed. And that's where I came up with this technique. So my background, I'm Manuel. I've been a programmer for 25 years. I've worked mostly in like backend, embedded, low-level stuff. And I really like compilers. I really like Common Lisp, which also strongly influenced the concept in here. I haven't programmed Common Lisp for like 15 years, but it stayed with me. So what's an AST? An AST is an abstract syntax tree, which basically most of the data structures we deal with, JSON, YAML, are actually trees. And so an abstract syntax tree is just basically a special tree that usually represents some kind of syntactic structure. Could be source code, could be data, could be, well, I guess there's not much more than code and data. But what's the purpose of it? It's like this representation of, for example, code, specific languages, or even specific data allows you to abstract away, allow you to basically have a framework to do transformation of these structures and working with them that is not just ad hoc, where you just don't think of them as a data structure, more as like a meta approach to it. So what do we use them for? Like programming languages, markup languages, data serialization. So everything that's JSON, everything that's YAML, XML are all kind of use cases to represent trees. So what does this look like? We have here a JSON structure, very, very, very common, right? Could come as a database out of a REST API. And if we represent it as a tree, which I guess I have to zoom out, yeah. As a tree, it kind of looks like that. You have like a base node, which is going to be the fact that it's an object. Then you have like 4 attributes, and then you have the value of the attributes. And in some cases, you maybe have like a sub-object, and then you will have an array. I'm going to go pretty quickly through this because I want to get to the interesting stuff. But for people who are not familiar with this stuff, this might be a little bit more to take in. But I hope it's clear so far. And so YAML, you'll see, is like kind of the same tree. You can see that maybe you can represent these objects with a different node. Here it's a person, even though this is also an object, right? But you can choose how readable you want to make your tree, how structured it is, what kind of nodes you have in there to make this most easy to work with. HTML is the same thing, right? It's like HTML is pretty much clearly a tree. XML in general has been built as a rich way of representing trees where nodes can have attributes and schemas and all kinds of things. So programming languages, if you have this Python structure, you'd be like, oh, this is like less evident to represent as a tree. And this is one way you could do it, for example. It's like you have a function definition that has a name, has arguments and a body. So that's not visible here, but it's part of the programming language itself. And then you have one argument, could be richer, could be like a typed string, depending on how you parse your data, and then you parse your source code, and then you can have like these different representations. So what's the difference between a parse tree and an AST? That's more fuzzy. I don't know if I even like agree with this split, but often you will have parse trees that are used for compilers that are much, much richer than what is necessarily nice for a human to deal with. This is especially true if you parse C++ with Clang. It's like absolutely insane. So some people call this a parse tree when it's like more in the context of a compiler, like a grammar parser, where you can see there's like a lot of intermediate nodes that are maybe not that useful. And then an AST is usually a compressed version of this that is more suitable for certain types. A very concrete example is tree sitter, which is a parser for many programming languages that is geared towards editors and tools and not compilers. So the tree sitter trees are usually pretty simple, very readable, so that you can work with them with an editor, plugin, and other tools. So how can you work with ASTs? How can you like basically interact with them? One way is to just build a node structure with a value and children. Like that's pretty much all you need. You can create the nodes, and then at the end you have your tree. So after this little intro, which I hope was not too compact, I hope you were. So are there any questions for someone who's maybe completely lost? Otherwise, I'll move on. And if you have a question, put it in the chat.
They are all dead, I think.
So where does
this
become useful?
I think it's okay.
Cool. So where does this become useful actually in the context of LLM programming? Well, it's like with ASTs, you have a lot of well-established design patterns that have been like used since the first structured programming language came out with COBOL, and then later, over time it became more and more formalized. But I guess since the 80s, we kind of know how to parse and work with programming languages or data structures. And one very interesting pattern is to do a tree walker. So basically you define a function that is then called by a walker on every tree. Could be depth first, could be breadth first. There's different ways of doing it. And what you can do with an AST walker is like analyze the code, right? Like analyze your tree, say like, oh, is there like an integer where there should be a string, for example? Or are there for loops in my code? Another one is like transform a tree to a new tree. So you could say, and we'll get into concrete details, right? You could, for example, add a log line to every function call. You could do much more complicated transformation, which, for example, transform from COBOL to C++. The key concept is just like it recursively walks through the tree. So for example, if we have a very simple expression like A is equal to B plus C times D, which has a very simple AST structure like this, then if we represent it with our Python that we had before, we can now define basically evaluate, which is a function that is being called for every node and also has an array to store variables, right? So it will go over every node and it'll be able to access a hash map that's called variables. How do you interpret, how do you build a calculator? Well, you look, is the node value equal? Then we're going to evaluate the right side and then we're going to store it in variables, right? And then we return the variable value. If the node value is a plus, we evaluate the left side and then we evaluate the right side and we add the two. And the same for multiplication. And then if it's just like a straight value, then we look it up in the variables. This looks absolutely trivial, right? Like not trivial, but to me, I had a lot of problems understanding, well, it's like equal is calling equal and then plus is calling plus and times is calling times. Like where's the interpreter in here? And really the interpreter is just like, it's basically this, it's like encoding the rules. So this took me a lot of time to kind of understand. And I was walking through this book, which is called Structure and Interpretation of Computer Programs, which is basically a book about programming language construction, but for like weird wizard nerds. So it's like, the way it's explained here is like kind of like a trick kind of way, which works for some people. And then for other people, it works less well. For me, it was pretty hard to go through this. So there's a bunch of other books, which I'll recommend. I'll put the links there in the handout that were easier for me to understand how this actually conceptually works. But what I'm trying to show here is that evaluating an AST is usually some pretty simple, straightforward code, which is like, well, if there's an equal, just put an equal. If there's a plus, just put a plus. So building a whole calculator that can evaluate these kinds of expressions is basically these 10 lines of code. And then you can evaluate this with a certain value of variables, for example. You can do the same with libraries, right? Like parsing Python is actually creating the AST is probably the more complicated part of a lot of these things. So Python has a module called AST. This is Python centric, but pretty much every programming language comes with such a module, and you can just parse straight code. So if I take the same code and I parse it, and then I dump it, I think, well, I don't have it here. Why don't I have the example? Well, you get to try this out for yourself. And then what you can do with the AST module is that, oh, there is an AST walker. In fact, there's an AST node transformer that you can already use, which is a little bit more complex than the function that takes a node that I was showing before, but it will call a visit function based on the node definition, and that allows you to do create, for example, new statements. So what this little visitor does here, the class print adder, is it will add a print every time you call a function, right? So you can have your normal code, def greet is equal to return hello. You can transform it, and then when you call it, it will, when you print out the modified code, it looks like this. So a really powerful way of doing something that you think is very complex, which is like transforming your source code, right? Is actually really not that hard. It's like adding two nodes and then inserting them. So what this allows you to do, for example, in terms of like, for example, vibe coding on legacy code, if you do need to transform old log structure statements, for example, into a new logging library, you can program like an adder, like a node transformer, let it run on your entire source code. And then maybe there's some special cases which are really hard to program, to capture. For those, you can just use the LLM, right? And what this does is that creating this transformer with the LLM is like maybe 100 tokens, 200, 1,000 tokens, but then you can transform your entire code base in the same deterministic manner and iterating on this transformer. And then for the few edge cases that might still exist, for example, instead of spending a lot of time adding those to your transformer, just use the LLM to do the more magic way of transforming things. So here, for example, this is a transformer that will look at the return value of a function and just add like another print call, for example. So this allows you to transform code like this and just have these expressions at the end. It's not necessarily pretty code, right? Because it hasn't been written by a human. It's just like some programmatic thing. So sometimes it looks a little bit weird. But it can be really, really helpful to do these things. The other thing you can do is like once you have an AST, you can just like, generate the code from it, which we've seen. So I'm going to skip over all of these things, and then real world use cases. This is where it gets actually interesting, right? It's like, why am I talking about all of this in the context of LLMs? There's a lot of things that are hard for LLMs, especially in like big code bases where you want deterministic ways of doing certain things, and you don't want to spend like hundreds of thousands of dollars on transforming like a 5 million lines of code base. So things you can do, for example, is create custom linting rules. So matching the AST, like a linter is basically using the AST and then recognizing certain patterns and saying like, no, don't do this, right? So I could create a linter that, for example, recognizes that you shouldn't use a class called container within a class called context. I don't know. In React, for example, you can create a linter, and the linting results are going to be shown to the LLM and most agent tools at this day. So you can think of a linter rule as kind of a dynamic prompt. It doesn't need to necessarily flag an error. It could also just be like, oh, you're working in this package, like be sure to include this other file, for example. Could be a linting rule that you can apply, which is really useful. You can use it to optimize code. If you recognize certain for loops, then you can do all kinds of compiler optimizations. can be pretty useful. You can do large scale refactors. You can generate tests and documentation in more code. Like you can do scaffolding of classes. You can build all kinds of tools. And let me see, what time do we have? It's 17. Okay, I'm pretty fast. That's good. So let's do some vibe coding though, so that we get something to show. I'm gonna try to use Claude AI just because usually it's a little bit faster. I'm not sure. I'm not going to show cursor and all this setup. I'm just going to do create a biome linting rule. Biome is the TypeScript way of doing linting to match the fact that classes called container shouldn't contain any React hooks. So this kind of work, when you do it by hand, is horrible. Like, to me, it's really, really hard. It's really, really frustrating. It's not fun. It takes a lot of time. So usually no one writes linting rules because it's just so annoying to write. But if you do it with an LLM, especially these days where they become really good at certain libraries, you can just do it. You can just say like, I don't like this style guide, and then get a linting rule for it and just put it in. So it used to be much harder to write this kind of code because every AST library looks like every other AST library, but the difference is very subtle, right? Because every programming language has function every time, right? So, however, these days with the powerful models we have, especially if you add the documentation, these things are fairly robust. And suddenly you add this to your code base, and it's pretty sure that the LLM will never add a hook to a container class because it will be immediately flagged. And not only can you do that, but you can also provide, fixing things, or you can say like, please LLM, look up at this markdown file how to do certain things. And then the LLM will see that and be like, oh, I have to like move my hooks into our Redux, blah, blah, blah. I already have the documentation for it. I can go straight ahead and do it. So really, really powerful, right? You can do exactly the same kind of thing where you can do Python AS. Oh, let me create a new example. For example, I want to do code transformation. I have an old legacy code base, so I can create a Python AST based program to transform all our banking legacy foobar database statements into modern banking database queries. So, I mean, this is like a nonsense prompt, obviously, because this doesn't exist and it doesn't know anything. But, right, I mean, this is not what I wanted, actually. Assume these are complex query builders.
I have a question for you, Manuel. Eric is asking, is there a name for this pattern of generating things that changes the code rather than the actual code in general?
I think it's often called metaprogramming, I think.
Metaprogramming. Okay.
You can also think of it, code transformation, code utilities, compilers, like
But you do not need to work at Meta to do metaprogramming, right?
Well, it's called metaprogramming because it's code that works on code, I think. So in Common Lisp, for example, it's a very common thing to define macros, to define things that, because when you write in Lisp, you basically write in the AST directly. So it is kind of easier, I think, for Lisp programmers to see the structure of the code in here. So what's really useful here, legacy code and modern code, is that you don't even necessarily need to prompt it from a AST kind of view, right? Because like LLMs are really good at matching patterns. So if I have the old code by hand, I can kind of write, oh, this is what the new code should be like, and then just give the old and the new example and say like, please make a transformer for this. So if I have the legacy banking service, I'm just going to put this in here, but not put the AST transformer. So I'm just taking legacy code, new code, putting it into Claude AI, saying write a Python AST transformers to go from legacy to modern, put my 2 code examples, and then, oh, this is greatly formatted. And then we'll just write, a transformer. You can generate a ton of examples for it, which is also something that's really painful to do by hand, right? And usually it will like understand things pretty well. So let me see. Create a bunch of input examples for edge cases. So you can pretty easily generate a bunch of input code. Every time you run into a problem in your legacy code base, you can add it as an example, right? Like, and so refine your AST transformer just like based on concrete examples without having to do this mostly boring, straightforward kind of matching, which is really hard to do for humans, but is actually pretty robust and fast to do with LLMs. So here, this is a quick way of generating a bunch of input code that you can use as unit tests, for example. And this is, yeah, I'm not sure why it's not formatting them correctly, but I hope you get the idea. I'm not going to run this because the time is pretty short. But a really, really, really useful technique, right? Like the fact that you have linting rules for all your weird guidelines, plus links to the documentation on how to do it is like great. I used to do it before LLMs even, when I had freelancers from like Upwork or so working on our React code, to just like force them to follow our guidelines instead of like using their own weird programming style. Or like a certain way of doing CSS rules, that kind of stuff, right? You can, this works on CSS, this works on like data structures, this works on SQL. There's a ton of parsing libraries out there, including TreeSitter, that you can use to do this kind of work. I'm going to stop there. I'm going to go back to my slides. So even last week, I built a tool to convert Go slog statement to Go zero log statements. It worked for like 95% of the cases in our code base, and then the last 5%, which are often like the really hard edge cases that you encounter when you do compilers or code transformers, those I can just say like, hey, LLM, just like do it by hand. Yeah, Adnan, it's like, it's not new. This is a real old technique that is really useful. So I'm gonna, oh, I guess this was the last slide. So this is perfect. This was the AST part of the talk, mostly to, excuse me, establish the like the ground structure, and then these kind of like code oriented use cases. So it also means that if you're doing a certain type of work, you can create your own linting rules for just this ticket and then just throw them away, right? It's like, it doesn't, because the code is so cheap to generate, suddenly you have a much more flexible approach to these things. And if you think of a linting rule more as a prompt, you can create a bunch of prompts that are really just custom to the work you're doing today, and then just throw them away, right? Like take your ticket description, maybe do an example by hand, and then say, make me rules for this, use them, and then throw them away. Before, it was so expensive to write a linting rule that you wouldn't even consider, writing like 10 linting rules for your work today. Now, if I have to do a certain type of CSS today, I can be like, I never want to use the color blue, linting rule. So yeah, JavaScript bundlers, I'm definitely not an expert. I used to use ESLint, and it was really painful to do custom rules in ESLint because they need to be packaged as their own package. So you need to have like, I was using Yarn workspaces at the time. That was really painful. Biome makes it really easy to just put that stuff in. Then as far as, I don't think you need to necessarily do it as part of the build process. Like, it's more as I use this like AST code transformation thing, maybe more as a, either for linting or for like one-off tools. As far as bundling, like I don't think I can help you concretely, just because bundlers mess with my head as well. So anyway, this was the AST part of the talk. I'll share the handouts. There's book references in there. There's much more example code that you can look at. But for the sake of time, let's move on to the DSL part of the talk, which, does this work here? Does this refresh? Yeah, where does it go to? There, no, what? There we go. So what are domain-specific languages? It's like, well, we've looked at ASTs mostly for existing programming languages, right? But you can create your new languages that are just like specific to the thing you're working with. So going to skip the definition. It's basically, you know, a programming language for a particular problem that's really like constrained. Maybe you don't need for loops. Maybe you don't need like class definitions. Maybe there's like, you don't need anything except defining a business process, for example. So for example, this would be something like a very simple kind of pipeline data transformation DSL, where you can load a file, you can filter it, you can sort it, and maybe export it. And the corresponding AST is, as we've seen, it's also just a tree. The YAML is pretty much the structure of the AST itself, right? Like there's not much difference except uppercasing things maybe. So it's really easy to, I like YAML because it's readable for humans. JSON, I mean, JSON is valid YAML, but the JSON way of representing things with the curly braces and all of that, it's like, to me, it's harder to read. It's also a little bit more tokens, which was, it doesn't really matter these days, but it used to really matter back then. And what this means is that with all the AST techniques we've seen, we can actually apply this to our own ASTs. We can create our own programming language, in quotes, or data structure for our very specific business domain, and then use that to maybe create queries out of it. And if you think, for example, about class definitions, function definitions, those are all kind of like tricks to create your own programming language, right? It's like suddenly you have certain patterns, you have certain class names. They're just a way of making a more generic programming language look like something that's domain specific. So all these techniques, code validation, linting, transformation, interpretation, compilation, you can do on your own programming languages, and do a lot of nice things with this. So for example, you can define test cases very easily. So this is more like a data structure oriented thing, but for example, I could put some specific Python code in there and then compile my test cases down to Python, or maybe interpret this little Python package passage in here, and so get like a very rigid structure that I can deterministically validate, deterministically interpret, and then still have like a lot of flexibility in there that lets the LLM shine, right? Like the LLM would be great at pattern matching and saying like, well, in this case, maybe I should put in a little bit of code. Gives it a lot of flexibility. So I don't know how useful that slide is, but for example, you could imagine a little YAML DSL for UI layout, right? You have a window, it has a title, it has a size, it has a list of components. They can be like different types. Nothing too crazy here. It looks almost like HTML at the end of the day. But suddenly you can transform it into code, for example, right? So either at runtime, either at code generation time, for example. And this allows you to kind of sandbox the execution as well. So you can be pretty sure that when the LLM generates this and it's not able to put in like custom code, then it's probably very safe. It won't be able to delete your hard drive, right? Of course, this on-click is like, you need to be a little bit more careful about that example, for example, but you could decide, oh, the LLM doesn't have the on-click function. That's like something you need to write by hand. You can do the same for like validation rules of a form, right? Like there's plenty of libraries that do this kind of stuff. The thing that's great with LLMs now is that these libraries that usually are pretty expensive to do is like very cheap to do now. Create a minimal because we're using Sonnet YAML DSL to do form validation rules, to encode form validation rules for a agriculture business. I like adding these kind of weird domains because it makes it easier to see what is the DSL structure, what is the domain structure. And basically what I do here is, instead of like me creating a DSL, I will ask the LLM to invent its own language, because by virtue of the LLM generating this language, it's probably a language that's pretty good for an LLM to generate. Sonnet always does like a little bit too much stuff, but it comes up with like a pretty simple kind of DSL. And you can see here, this kind of invented very domain-specific rules here. If I then transpose it back to say e-commerce, this will be much easier to see. If I had asked for e-commerce straight away, it would have been a little bit more harder to see, oh, this is e-commerce, this is like programming stuff. So this is a pretty easy way of like generating XML, DSL examples. And what you can do now is like implement the validation code for 3 of those rules in TypeScript, for example. So generating your own custom, say, validation rules for your own little domain is now almost free. And this is code that I'm sure everybody who has been doing form validation has seen before. This is so boring to write usually. And then it's even harder to write a bunch of examples to test it, right? So, I mean, this is getting crazy here. But what you can do is like create 10 examples, and you can very easily like generate all these like use cases that are actually the hard part of building a system like this, is like thinking of all the weird cases that you could have, or making good examples. So this is a nice way of building a pretty robust DSL. And of course, if you already have existing DSLs and things like this, you can generate a lot more use cases, but you can also generate a transformer that transforms it into a more powerful DSL, for example. So I'm going to stop here. I'm going to say like make it terse, minimal, but spec. We're going to take the spec, and then I'll show you. Yeah, Georgie, this is, I would just like basically, oh, am I showing something more than the slide? Are you?
No, we cannot see.
Oh, God damn it. Okay, I thought I was sharing the browser. Okay, I'm very sorry, because you're missing all the work I was doing. I used the wrong browser. That was the issue.
Sorry for not mentioning. I was looking at Martin Fowler domain-specific language book.
Yeah, I'm sorry. This is my fault. So I hope this will answer your question, Georgie, as well. So what I did, I opened Claude, and then oh, by the way, so you missed all these linting rules? No, those I showed before, right?
No, yeah, you showed it.
So here I basically asked the LLM, hey, create a minimal YAML DSL to encode form validation rules for an agriculture business. And then what it came up with is like, oh, look, this is what a rule looks like, right? So you can have rules like minimum length, max value, pattern, and then you can have very specific domain-specific rules like, oh, maybe the temperature in a form shouldn't be between a certain range, or different other examples. And then it gives you like a couple of examples, like what does this look like for crop registration? You have like standard rules for the name, but then you also have things like the field size in acres, right? So this is a much nicer way to encode a rule for an agriculture business, not only because it's like nice to read, but it's easier for the LLM then to generate the right validation rules for field size, right? If you use any kind of size and you say like, please use our DSL to validate it, it will be more deterministic than if you just give it a much more generic form validation, right? Where sometimes it will use like a numeric validation, sometimes it will do like this, sometimes it will add 2 fields. Like this is much more robust because your prompts tend to be in your domain language. So I see we have 20 minutes left. So I'm very sorry that I wasn't able to show this while I was doing it.
No, that's
So the second step, once you have created the DSL, right? And I love asking the LLM to generate DSLs because it also gives me ideas on what to do. So for example, if it's like create a DSL to manage cows, this will be way too long because it's Claude, but you could do the same in ChatGPT, see what the differences are. YAML DSL is usually the right name to do. And then here, you know, while I create different languages that are interesting, then I like pressing regenerate, see different ideas on how to do this. Very, very nice and useful. So the second step then is like, okay, well, writing the code to do all these validations is kind of very boring, right? Like, I think most programmers, when they see this, already know what the code will look like. It's just like now you have to type it in and validate it and do all of that work. So here, LLMs make it very cheap to just create all of this validation code, right? Which is really not interesting. You have to like create error languages, error messages for everything. It's just like very painful, at least to me. And then the really useful case is that you can make a lot of examples, which is, I think, the hardest part of building like a good DSL is just like, oh, well, I want to not only have a good domain representation, but I want a lot of examples to either communicate to other users, to do unit tests, to give to the LLM as examples. And then you can do a very minimal spec that you can then actually copy paste, put into your own cursor as a document to reuse always, right? It's like create 10 forms using, and you don't even need to add very much. You can really just paste 5 examples and it will kind of understand what this is about. Oh, maybe not pro. let me go back. Switch model, auto. So I think that's what I was showing in here. Yeah. All right. So I hope I caught up with these things. Let me see where we were at. Internal DSLs, data validation. You can do it for like network configuration. And then this is what I was showing you, like create YAML DSL is like, it's like a magic abracadabra, right? It's like, it's not even that I think about it, it's just like something that I now just put in there. And so what are the advantages? It's like, it's way less tokens to generate, say, a form validation using the DSL than even using a form validation library. It's much easier to say like, oh, this is not what I wanted to validate it. And as such, it's just like easier to iterate. You don't have to wait 15 minutes for it to write like a 2000 line validation file. And the really interesting thing is that usually this is kind of readable by non-programmers, right? Like if I'm sitting with a customer and I tell them, you know, this is the values for crop, they are kind of able to understand what this means, right? Because it's almost English language. And so it's kind of easy for them even maybe to modify this stuff. Maybe they can vibe on it, or you can build like a visualization, right? So this is another thing that's pretty nice. Once you have a spec, make a minimal web app with a few presets to show the validation rules. So you can build little visualization applications very, very easily for non-programmers or even for programmers to visualize, you know, these rules, which is often very, very useful. If you have like a network configuration DSL, then visualizing it graphically and maybe even modifying it graphically, adding or removing node. Yeah, it's very useful for no code basically because it's this intermediate formal form that is easy for humans to understand and thus visualize, easy for LLMs to validate. And then you can create tools like this. Like if you look at the prompt, it's this and it's this, right? It's like 30 tokens of prompting and I get a full application that's usually pretty valid, right? And so you can see the rules that are active here. You can see different kind of things. right? So basically everything built in 2 minimal little prompts. Who cares what the code for this is? Because it allows users to do any kind of thing. So like add a section to edit the rules, right? You can even add like a little chat in here, which I'll show. I hope this will work, but going back to the slide just to see that it's very safe to sandbox, right? If you have a DSL, you have full control over what it's able to access or not. You don't want the DSL to have network access, don't encode network access, right? So you can now generate a lot of basically vibe coded code. It just generates this thing that's very safe, and then you can, you know, hack away. It's like there's not going to be many issues there. And then usually YAML is pretty nice because you can fairly easily like do a streaming parser, kind of a hacky way. I miss XML, but XML being dead is like, I can talk about this for days. I'm going to skip this part because it goes deeper. This like kind of DSLs look like human language is like a deeper topic. But yeah, validate, preview, interpret, basically did it in like 2 prompts, right? So if we look at here is like, I don't know, where's the editing? Click edit rules. Where? Okay, vibe coding, great.
To
Rule
refresh,
editor. Maybe, but usually it refreshes. I don't know. I kind of hate Claude these days. Yeah, it doesn't seem to have an edit rule thing. I mean, also add a real Claude chat integration where I can prompt a new DSL rule. Use a modal to enter the API key. So Claude artifacts allow you to add real Claude calls in it. So you can very easily actually build a vibe coding application that's custom for your customers. And you just say like, you know, just like chat with the thing until you have your rules ready. And then we'll take the YAML. We're pretty sure it's safe. Maybe we'll look at it a little bit to validate it. And then we can just put it into the code base. So suddenly your customer is part of the programming team, right? You just let them, you know, you can spend all Sunday tweaking the form until you're happy with it because we don't know really what you're after. And then on Monday, we'll integrate the YAML. And users, I've worked a lot in e-commerce and like small family businesses. They can spend days tweaking this. Like they love doing it. And as programmers, it's really hard to create them, right? It's like a lot of back and forth. You have like specification meetings. You're like, oh no, field sizes should be X, Y, Z. And then everybody's like tired afterwards. And here it's like very exciting for users to realize, oh, I'm actually, you know, these rules are actually the ones I created. So if we do load, oh, what is this? Oh, it created this is the different DSL. Well, you can see how far you can get, even with like non-YAML DSLs, right? It's like suddenly you can create all of this stuff here. So I hope that this works. It didn't toggle edit rules mode. Okay. Add set API key. So let me see if I can quickly get my API key, which is echo Anthropic into the clipboard. I'm gonna save it here. And then, yeah, add a field size from 10 to 500 acres. I wonder if this is gonna work. Kind of, almost, probably had some problems parsing, but you get the idea, right? It's I don't know, this is a little bit broken. This is obviously a more complex application. I'm not going to get it done in 2 minutes. Sometimes it works, sometimes it doesn't. I'm just going to press retry because why not? Oh, with extended thinking. Let me do that. Extended thinking. And then maybe turn, oh no, I can't switch to Opus, huh? All right, just for the fun of it. Yeah, so interpreters, I'm going to skip that. You can look it up in the handout, how to write like your own little interpreters. I usually just ask the LLM to do it. There's a bunch of different patterns. We already saw the AST walker, which is a visitor. Those are actually not that useful. What is really useful is doing multiple DSLs, right? Where maybe transforming from your agriculture DSL to, say, some legacy database language, like some kind of COBOL query language. Maybe that's hard to do, right? It's like you have some very generic that allows you to do web UIs and whatever, and you want to compile it down to COBOL. How do you do that? It's like, well, you can create intermediate DSLs to make a step-by-step transformation. So it's basically compiler knowledge, right? Like compilers do this a lot, where they will take the source code, then they will create a very rich parse tree, then they will transform this into a data structure that more represents, like, say, variable definitions and types, and then do multiple. And then at some point, you will have something like the LLVM intermediate representation, which is, it's not assembly, but it's something that's very useful to generate assembly for a lot of architectures. Yeah, thank you, Florian. Have a good day. And the difference between interpreters, right? Like interpreters is just like processing a DSL at runtime. Compilers can create more generic code. So maybe we'll add this. I don't know if this worked. Oh, this is not what I wanted here. Add a data section to edit the rules with AI. And it didn't even write it. I don't know what Anthropic is doing these days. Like nothing works. What you can do here, for example, if we use the cow DSL, with milk and fields and whatever, what you can do is like create a code generator that takes a DSL file as input and outputs protobuf definitions, right? So a very standard use case of code generation is just like generating IDL definitions for protocols. And protobuf itself is a DSL, right? It's a DSL to specify how to encode certain fields that then can be used by many, 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 many different languages and protocols to do their data encoding. This kind of code, again, is like so tiresome to write, because you need to look at the definition and you're like, okay, I know what code to write. It's just going to be very tedious. So this is, again, like having a compiler for a cow-specific language with a visualizer, with all of that. This is like 2 prompts. Create a DSL to manage cows. Obviously, you would iterate a little bit more in real life, and then create a code generator that takes that and creates DSLs. If you had done this without these 2-step things, or say like, oh, I want to encode cows as gRPC, obviously this would have been like much more complicated, much harder to debug. Here it's almost trivial to debug, right? Yeah, I have the DSL book somewhere. I don't know, but I have like I think I linked that book in the handout, which I'll I guess for people who want to see the handout, and it's going to be in the recording, if you go to publish Obsidian MD/manual, and I know the browser doesn't really show it, the URL. So it's publish obsidian.md/manual. And then if you look for AST's DSL or AST handout, you'll find the handout that from the talk I gave a year ago already. That's time goes fast. So you'll have everything in here. You'll have all the code to test. The code has been validated. So all of this code should work, even though it has been vibe coded. It was a different world back then before agents. With agents, it's even more effective, right? Like the agents are able to validate their stuff on their own. And then I'm going to skip most of these because they're just like extended versions of what I've shown. Some languages use DSLs by using like language tricks themselves, right? Like Ruby is pretty baroque and allows you to do things like this. without even writing a parser. I'm not a fan, but works well. Common Lisp is much more my jam, where you basically work as AST compiler anyway. So this is really, really useful when you do infrastructure work, right? Anybody who has like written AWS infrastructure with an LLM knows how freaking painful it is, how absurdly complicated it is to replicate things deterministically, have your IAM rules like properly deterministic. So what you can do here is actually work and define the way you think about infrastructure and then generate the Terraform or CDK or whatever you want out of it. So very, very effective to create infrastructure code without going crazy. You can define, oh, I want a firewall. Maybe you can define like a specific DSL for rule ownership, maybe a specific DSL for the log formats to do, and then generate all your like cloud formation. Sorry, that's not what I wanted to say. What's the logging thing in AWS CloudWatch? Cloud something.
Don't know. But you did recently something with Terraform, right?
I did a lot of Terraform recently. I mean, models have gotten pretty good at the Terraform. And in a way, if you think about it, a Terraform module is a way of doing a custom DSL, right? So in a way, you can just like generate Terraform modules, but in some cases, it might be very effective to use this like intermediate thing, even if it's just for the time of a single session, right? Like maybe you don't want to check in like 18 DSL interpreters every day. So you can throw them away once the Terraform is written, or maybe just leave the specification mark down somewhere and say, you know, this is good. This is code that was so expensive to write that as soon as someone wrote like a new DSL, everybody would use it. Now it's like almost so cheap to write that no one's going to use these things because it's easier to invent your own than kind of reuse something that already exists and won't like fully fit your use case. We have 5 minutes left, so I think maybe we should take some questions if there's some questions.
Thank you very much, Manuel. It was awesome.
Yeah, you're welcome.
Really, really cool. Do you have any questions, folks?
Yeah, no, this thing is not working.
No questions so far.
No questions.
I have a remark.
Sorry?
What, and then? Sorry?
I have maybe one. What is the added value of the LLM in all this? Because like if I take your likes example, we use state management of infrastructure with a YAML state for more than 10 years with Ansible, with SoulStack, with stuff like this. So yeah, we moved a little bit to Terraform because basically with, let's say, cloud computing, we focus less and less on the exploitation system configuration and other tools configuration and more into just provisioning the boxes. And that's why Terraform has gained more, it was more spread, and these kind of tools were less spread. It's fun that now we are similarly getting back to that. I can understand why an LLM could be used to generate, let's say, ESLint rules or stuff like this more easily than by hand. But it's true for any code, basically. So an ESLint rules is painful to write, and you're happy to use an LLM for that. A form is painful to write, and it's nice to use an LLM to write it. An interface to convert to code and CSS and whatever is painful to do, and LLM can do it fine. So I really like these techniques because we use them for a very long time when building compilers, transpilers, and stuff like this. Yeah, I'm a bit lost in the end.
Yeah, so I see. I think I mean, it's a very deep question, right? And if it doesn't have value for you, then it's like
no, it has
to
value,
kind of
but I have issue to process everything in like, I'm an old machine, so I need time.
Yeah, no, I know. I've been going pretty fast. I see three values. One is obviously this like very tedious pattern matching kind of code. LLMs are very good at, and it saves a lot of time, right? Like, so just writing something that like recognizes nodes in a tree and then transforms them, I at least find it very tedious to write,
Yeah,
and it takes
I
a lot of
agree
time.
with you, but I don't know any language where you don't have an existing linter and with not the capacity to add custom rules to the linter and do that.
Yeah, so that's great, right? Like writing custom rules is a little bit easier. It's still tedious, but I build a lot upon that, right? Like programming language always come with like some kind of AST library with linting systems. So those I target directly. Creating your own DSLs, I see that very useful in terms of it's a very sandboxed way of executing LLM generated code, right? It's if I have this as an output, to describe my infrastructure, I know that this won't create like some weird stuff that's insecure, for example. And so to me, that's like a great advantage. It allows me to use the formal code generation capabilities of an LLM while staying safe. If I don't want my code to do network calls, well, I don't put network calls into the interpreter, and then I can just like vibe code away as much as I want. And that's a third advantage that I think I really like, is like it's so easy to create complicated examples while staying in domain language. So I made up a simple DSL to represent like some kind of data processing infrastructure. What I can do now is like create 3 examples for the banking business, simple to complex to medium complex.
So basically what you are saying is, correct me if I'm wrong, is do not use the LLMs to generate code, but use LLMs to create a higher level of hierarchy of language that is simpler, and then the transformer code will, your own, let's say, compiler, transpiler will manage to have something like this, and so you will have something more deterministic.
Yeah, exactly. And it also uses less tokens, right? It's like if you ask it to write the Terraform for, say, a data pipeline like this, it's going to be thousands and thousands and thousands of tokens. Your context window will get too big. It will like change styles when you start a new session. Here, in like 2,000 tokens, you can get a full infrastructure description, and you know, you have your context window is still there, and you can like refine it, say like, no, I don't like this code, like please change it. So this is a really good technique to use with small models. For example, like if you code with something like Qwen 3 Coder Local, which is not that great of a model, these things work really well. Because the one thing I haven't gone into, and I know we're at time, I'm just going to spend 5 more minutes, is this is a very powerful prompting technique, right? If I say there's infra and it has a name, it will always put a name, but it won't put a subname. But if you don't say that, the LLM will add all kinds of like weird little things, because it has so much flexibility to add fields, to add other things. Here with a DSL definition, I can basically very shortly prompt the LLM to do to have the right output structure, right? Like this is what I was showing in here. Where was it? The only thing I had to prompt here to make it create 10 forms is this very, very terse prompt. I don't know how many tokens this is. Let me look.
Yeah, I agree with you, but if you add much more context to your LLM, even if you specify the DSL, since the DSL would represent only a fraction of the whole context, it might not respect it.
So yeah, that's true. That's why this technique of intermediate languages is something I use pretty often, or used to use, where...
But isn't it the same of saying that SAS is now commoditized? So basically SAS was a way to simplify stuff on top of other stuff. And now a lot of people are saying that since 6 months and 9 months, SaaS will become obsolete and it will be a commodity. And so basically, it's a more technical way and a more subtle way, but to say the same thing.
Yeah, this is a way of commoditizing, as you call it, like toolify your domain.
Okay.
And the thing is, because it's so cheap, and that's maybe something that's hard to convey, right? Because you have to do it a few times. This is so cheap that I can throw everything away. I mean, I'm going to close the tabs. I don't know how many I created today. So that means if today you have a ticket to say, I don't know, convert everything to Kafka, and you only have like 10 instances of Kafka, right? In the past, I would have been like, okay, well, I'm going to spend 3 hours converting all my config files in a certain way. Today, it's much faster and way less tokens to say, create the DSL or the AST transformation to do my 10 Kafka transformation and then transform them. It's even faster than just telling the LLM, like, please transform the 10 Kafka instances, which is...
I see. I used, I mean, when you do such kind of transformation, generally, the first question you ask is, do I do it manually or do I write something to do it for me?
Exactly.
And generally, it's a matter of balancing the time and waiting the time and saying, okay, this is just, this will take me a few minutes, and so I will do it manually. This will take me a lot of time, so probably it's better to automatize, and sometimes you miss. And in that way, the LLMs save the time of writing the automated part. And so the equation, the ratio between are more often in the weight of automatizing than on the way of doing it manually.
Yeah, and often automating it is way faster than than doing it by hand. Like, that's the new world, right? It's like, if you think of JIT as just-in-time compilation, this is like, oh, just-in-ticket compiler.
Yeah, I agree with you in that. But
It's just-in-time prompting, kind of.
Yeah, I call it just-in-ticket compiler. It's like, I create a compiler just for this one ticket, then I throw it away.
So thank you very much, Manuel.
Yeah,
we will leave you to your day, and we will take the recording and make it available for your community. Okay, for you?
Yeah, for sure. I hope this was useful. This wasn't really too fast.
Yeah, it was really cool. Thank you very much. Have a great weekend, everybody.
Yeah, you too.
Thanks.
Bye.
Bye-bye.